Hi, this video is going to introduce you to exponent rules. So the learning goals for this video are to investigate the exponent rules, link exponent rules to area and volume, and then apply exponent rules to simplify expressions involving exponents. So we're going to investigate the first few exponent rules here. We've got some expressions over here on the left-hand side. What we're going to do is we're going to express these powers in just using regular numbers. We're going to multiply them or divide them to get a result, and then we're going to express that result as a power. So let's go through one example, and then I'm going to ask you to try to complete the rest of the table. So we're going to write 5 to the power of 5, so that's really 5 times 5 times 5 times 5 times 5. That's 3,125. So that's multiplying here by 5 to the power of 3, so that's 5 times 5 times 5, that's 125. So in this column here, we're going to just multiply that. So we're going to do 3,125 times 125. So that'll get us 390,625. I'd like to express this result as a power of 5. So I'm going to do a little bit of guessing, and let's see what power of 5 will get me 390,625. So I'm going to go, let's say, 5 to the power of 9. Okay, that number is way too big, so I'm going to lower the exponent. Let's go 5 to the power of 7. Okay, that number is too small, so let's go 5 to the power of 8. Okay, so that's good. So 390,625 can be written as 5 to the power of 8. So what I'd like you to do is I'd like you to express each of these powers as standard values. You're going to multiply them or divide them, fill in the result column, and then I'd like you to use a calculator and see how you can express the result as a power, indicated by these numbers here. Okay, so I'd like you to pause the video now and complete the chart. Okay, and when you're done, press play. All right, hopefully you're done. So I've pre-filled in the table because I'm prepared like that, and we're just going to fill in the result in exponent form column here. So 59,049 can be written as 3 to the power of 10. That big number can be expressed as 7 to the power of 7. 25 can be written as 5 to the power of 2. 81 can be written as 3 to the power of 4. And 7 can be written as well, 7 to the exponent 1. All right, now inspecting the exponent form here, and then looking at the result column, I've noticed that somehow a 5 and a 3 end up being 8, or 7 and a 3 end up being 10, and a 4 and a 3 end up being 7. So just by looking at it, hopefully you see that if you add these exponents, you end up with this exponent here in the result column. Now, similarly, if I look at the 3 rows about dividing, a 5 and a 3 turn into a 2. So that looks like they're subtracting. So 7 take away 3 is also 4. Yep, and 4 take away 3 is 1. So those are our first two exponent rules. When we have powers that multiply, and they have the same base. So you notice that they both have a big 5. Then that means we add the exponents. And similarly here, if we have powers of the same base and they're dividing, we subtract the exponents. So let's just take a look at what that actually means. We're going to write this out in long form. So we're going to look at these two examples in more detail. 5 to the power of 5 times 5 to the power of 3 really looks like this. These are the 5 5s, okay, that are green, and then these are the 3 5s that are repeatedly being multiplied. So if you notice that it's just a long string of multiplying by 5. So that's really 1, 2, 3, 4, 5, 6, 7, 8 of them. So I can write this as 5 to the power of 8. Now, similarly, if I divide here, I'm going to show that. We've got 5 5s on the numerator, and then we're dividing by 3 5s in the denominator. Now, when we're dividing here, these 5s can actually divide out. Okay, those 2 5s can divide out, and those 2 5s can divide out. And that's leaving us with 5 times 5. which we can write that as 5 to the power of 2. So again, 5 take away 3 is 2. And up here, 5 plus 3 is 8. So when we're multiplying powers with the same base, what we're doing, all we have to do is add the exponents. And when we're dividing powers with the same base, all we need to do is subtract the exponents. So let's apply the multiplication rule to determine the area of these two rectangles. We're going to use the area is equal to length times width. So this rectangle, let's say the length is x to the 4 and the width is x to the 3. So I'm going to write, instead of the length, I'm going to write x to the 4. And instead of width, I'm going to write x to the 3. So these two powers are multiplying, and they both have a base of x. So that means all I really need to do is add the exponents. So that's x to the power of 4 plus 3, which is 7. Let's take a look at another example here. So we're going to use length times width. The length here we'll say is y, and the width is y to the 5. So again, we get to add these exponents, but hey, wait a minute, I don't see an exponent here. Well, really, there's an exponent. There's a 1 here. So when you don't see an exponent, okay, really there is an exponent. It's an invisible 1. Okay, I'm going to write it in so that it makes it so it's visual. Here we get to add the exponents, so 1 plus 5 is 6. So we have here the area y to the exponent of 6. We can also do this with volume. So volume is length times width times height. So let's say the length is a to the 4, the width is a squared, and the height is a to the 5. Here, all these powers are multiplying, so we just need to add the exponents. So 4 plus 2 is 6, 6 plus 5 is 11. So this is a to the 11. If we look at this example here, length times width times height would look like x to the 4 times x to the 3. So all we need to do is add the exponents. Now this one has an invisible 1. So this will be x to the power of 4 plus 1 is 5, plus 3 is 8. Okay? So when we're multiplying powers that have the same base, we add the exponents. All right, let's take a look at another rule, the power of a power rule. Now a squared, remember all that means is a times itself, a. Okay? Now a times a is again just a squared. Now this is important because though 2 to the power of 3 squared, well that just means 2 to the power of 3 times 2 to the power of 3. And looking at the exponent rule just previously, remember when we multiply powers that have the same base, we add the exponents. So 3 plus 3 is 6. So this can be written as 2 to the power of 6. Here 5 to the power of 4 raised to the power of 3. Well, that just means 5 to the 4 times 5 to the 4 times 5 to the 4 again. Here, the powers are multiplying and they have the same base. So remember, when we multiply, we get to add the exponents. So 4 plus 4 makes 12. So let's take a look at the exponent form here and then the result in exponent form. The exponent here, there was a 3 and a 2, and it somehow turned into a 6. And then here we have an exponent 4 with a 3, it makes 12. So upon inspection, it looks like when you multiply these exponents, you end up over here in the result. So when we have a power raised to another exponent, all we need to do to simplify this is multiply the exponents. So that's 4 times 3. So in this example here, like we had, it was 5 to the power of 12. So the exponent rule for raising a power to a power like this, all we need to do is multiply the exponents. So right now we've got a rule for adding, subtracting, and multiplying exponents. Now the last rule that we'll look at is the fraction exponent rule. So 2 over 3 squared, well that just means 2 over 3 times 2 over 3. Now to multiply fractions, remember we just need to multiply the numerators and then the denominators separately. So 2 times 2 makes 4, and 3 times 3 makes 9. Now 4 can be written as 2 squared. That's 2 times 2 makes 4, right? And 9 can be written as 3 squared, because 3 times 3 makes 9. Now if we look at another example here, 2 over 3 raised to a power of 3. Remember, that just means we're going to multiply it, okay, so that there's 3 of them here. Now when we multiply these fractions, 2 times 2 times 2 makes 8. 3 times 3 times 3 makes 27. Now 8, again, remember, that's 2 times 2 times 2. That can be written as 2 to the 3. And 3 times 3 times 3 on the bottom here, well, that can be written as 3 to the power of 3. Okay? One more example. So 2 over 3 to the power of 4. Well, guess what? You just multiply it so that there's 4 of these fractions. On the numerator here, we got 2 times 2 times 2 times 2. That's 16. And then on the bottom here, when we multiply all of those 3's, you get 81. Now remember, on the top here, that's 2 times 2 times 2 times 2. That's 2 to the 4. And then on the bottom here, we've got 3 times 3 times 3 times 3. That's 3 to the 4. So take a look at what happens here. This exponent that was outside, outside the bracket, we can actually apply it to both the numerator and the denominator. So you see here, this 4 on the outside, you can actually put it and apply it to the numerator and the denominator. So those are the blanks here. So for fractional bases, the exponent applies to both the numerator and the denominator. So those are the 4 exponent rules, and we're going to just apply them to simplify some simple expressions. So we're going to write each of these expressions as a single power and then evaluate. So here we've got 2 powers that are multiplying, and they have the same base. So this means here we get to add the exponents. So we're going to write 4, and then we're going to add 3 and 6 to get 9. So I'm going to get my calculator. I'm going to figure out what 4 to the power of 9 is. Okay, so 4 to the power of 9, 262,144. Here we've got powers that are dividing, and they have the same base. So remember, when powers are dividing, we get to subtract the exponents. So that's going to be 6 to the power of, we're going to subtract those exponents to get 2. Now 6 squared, well, that's just 6 times 6. I can do that in my head. That's 36. Here we've got a power raised to another power. So in this example here, we get to multiply the exponents. So that's going to be 5 to the power of 2 times 3, which is 6. So I'm just going to quickly do that on my calculator. That's 5 to the exponent of 6. That's 15,625. Okay. And last but not least, we've got the fraction exponent rule. So this exponent on the outside of this bracket will now apply to both the numerator, right? So that's 4 to the 3, and the denominator. So that'll be 5 to the 3. So 4 times 4 times 4, that's 64. And then 5 to the power of 3, well, that's 125. Okay, so we've got 4 different exponent rules. One you add, one you subtract, one you multiply the exponents, and here they apply to both the numerator and the denominator. So let's write the expressions here as a single power. These powers are all multiplying, so that means all I need to do is add the exponents. So 2 plus 5 is 7, plus 3 makes 10. Here we've got multiplying happening and dividing happening. So let's just do it in 2 steps here. B to the 7 times b to the 4, that's b to the 11. We're going to divide this with b. These powers are dividing, so we subtract the exponents. Now again, I don't see an exponent on b here, but there really is one. There's an invisible 1. So I'm going to subtract those exponents, so that's b to the 10. Here we've got a bunch of exponent rules. So remember, in BEDMAS, we've got to deal with the exponent before we do any multiplying. So I'm going to write the p there first, and then I'm going to deal with this exponent here. That's so I'm going to do p to the 3 raised to the power of 4. Here we get to multiply those exponents. So we're going to have p to the 12. Now down here I can do the same thing. So I can deal with the numerator and the denominator separately. Okay? So this is p to the 5 raised to the power of 2, so that's p to the 10. So let's just clean up the numerator here. Again, that p has an invisible 1. So that's going to be p to the 1 times p to the 12. I get to add those exponents, so that's p to the 13 over p to the 10. And now they're dividing, so I subtract those exponents, so I have p to the exponent of 3. All right, what I'd like you to do is to try these 3 questions. You're going to pause the video, apply the exponent rules, express them as a single power, and then when you're done, you're going to press play and you're going to check them out. So right now, just pause it and give these 3 questions a try. Okay, good luck. All right, I hope you have tried them out. We're going to apply the power of a power rule here on the numerator. So that'll be 4 to the exponent of 7 times 3 is 21. We're going to write the denominator the way it is. Now, because they're dividing, I get to subtract the exponents, so that's 4 to the 10. Here, same idea. We have to apply the power of a power rule. So I get to multiply those exponents. So that's 3 times 4, that's 12, over a to the 2. Here they're dividing, so I get to subtract the exponent. So that's a to the 10. Here we've got a power of a power rule, we got multiplying, and we got division. So first things first, we need to apply the power of a power rule first. So I'm going to write x squared the way it is. X to the 3 raised to the 4 makes x to the 12 because I'm multiplying, right? And this is x to the 5. All right, let's clean up the numerator here. So these are multiplying, these powers are, so I get to add the exponents, so that's x to the 14 over x to the 5. Now the last step here, I'll just keep writing horizontally. Here they're dividing, so I get to subtract those exponents, so that's x to the 9. All right, so that's about as hard as we're going to go. So let's just come up with one important point here. When the powers are different bases, we actually can't use the exponent rule. So here I can't actually add these exponents, okay? Don't add these exponents, okay? Because the powers have different bases, okay? These are different bases. So when you have powers that have different bases, you actually cannot apply the exponent rules to simplify. Okay, that only works when the powers have the same base. Okay? So hopefully this video has made exponent rules pretty clear. So thanks for watching.